Hello everyone, welcome to our third video of our computer science series. This series will follow the AP Computer Science A curriculum, but you can also use it as an introductory course to learn coding. We code in Java, so all information will adhere to that. If you watched the last video, we talked about arithmetic expressions, so today we will discuss an extension of that topic, which is compound operators. Let's get into the video, but before that, please make sure to subscribe to the STEM Spot for more STEM content. Let's get started. So let's just review some basic rules that we learned from the previous video, just in case you haven't watched them. These are so in Java, it allows you to perform math following PEMDAS. So you can write different arithmetic expressions and assign them to variables, and those variables will then contain whatever the output of these arithmetic expressions are. So, as a reminder, we use what are called operators to, perform these arithmetic expressions. So, there's always addition, which you just add two numbers, subtraction, subtracting two numbers, multiplication, which uses the asterisk, which is something to note, division, which is just a slash, and this last one, which might be new, but it's modulus, which just essentially returns the remainder of two numbers. So, this is like this would just be used when doing division, but if you just want the remainder, not the answer to the division. So that's just a quick review of, the last unit because that will actually carry over into this unit. So today we're going to be talking about compound operators. So we learned from the previous video that those were just regular operators, but now we have something known as compound operators. So as you can see here, I'm just going to go down this table and kind of explain what each one does. So the first one, it's signified by two plus signs, and this signifies the increment operator. So essentially, you would just put a variable, and then you'd put the plus plus right after it, and this will actually increase the value of the variable by one. So instead of doing like plus, variable plus one to change the value of the variable, you can just do variable plus plus as a line of code, and that will increment the value. And I'll show you these examples later on in the video, but for now, just understand that it increments by one. In the same fashion, this is the the decrement operator, which will essentially subtract one from the variable, and it works in the same manner as the increment. So now we come down here to what it's like a plus equals sign, right? So you would do the variable plus equals, some number as shown here. If you see this x plus equals 3, and this just basically unravels to you're adding x plus the number that you chose here. So that's essentially changing the value of x, but it's doing it in a much shorter command. So, again, I'll show you later in the video how this is being simplified, but you can see here that this is just going to add the variable. It's just going to add the number to the variable itself, and in that way, it reassigns the variable a new value. So that's really important to remember. And the minus equals 1 works exactly the same way. It's just x equals x minus 3. Again, same with the same with the multiplication equals and the division equals. They all do the exact same thing, just different operators. So we're taking the operators from the previous one and combining them here. So just this little unpacking thing here is what you need to see. This x times equals 3 is another way of saying x equals x times 3. And again, we have it for mod. So, if you want to, this is just a way of simplifying these expressions. Okay, so that was it's pretty self-explanatory, but of course, let's do some actual practice problems so that you can get accustomed to these. So let's get into that. Okay, so let's get started now with some practice problems. I've just opened up our Java IDE, which is I'm using Eclipse right now, so you can just use whatever your teacher asks you to set up, or if you want to use Eclipse, you can just search up Eclipse and you'll find all the instructions to set it up. So I'm just going to be using this to kind of explain this concept in more detailed terms. So basically what I've start with here is I've just defined a variable called integer1 as an int, and it just equals 6, just some value that we put here. So if you can see in this line right here, it says integer1 equals integer1 times 2. Now, in a way, this is very redundant because there's a much simpler um, method to defining this. So multiplying the integer one value by 2 and assigning to it, and that's where compound operators come in play. So as you can see here, this is a much simpler way of doing it. It's a lot more concise, and a coder would understand this a lot better. So we're using the times equal right here and then setting it to 2. So again, just to reiterate, what's happening here is it's assigning the integer one value. It's overriding this value from 6. We had it as 6. Now we're multiplying this value by 2. So it would be 6 times 2. This is going to equal 12. Okay, that's how so now integer 1, if you were to print it out, it's going to actually print out 12, not 6 or 2. And again, here you can see this. I've just shown that this can be done with any kind of operator here. We see there plus equals 1 or minus equals 1. That's just the way that these compound operators can work as long as you do it in the proper syntax. And keep in mind, the proper syntax is that you always do this plus sign or the minus sign or whatever the operator is first, and then you put the equal sign. That way you won't have any error. Okay, so let's come down here, and this is going to be our first kind of problem set that we're going to work on. So I've just put a little, a couple lines of code, and I would just like you to write down what every single line is going to print. So this would be the first line, and then this would be the second line, this would be the third line, this would be the fourth line. So I want you to write down what every single line is going to print, and then we'll go over it. All right. So I'm going to give you guys a moment to do that, and then I'm going to reveal the answers and explain it. So just pause this video now and try and figure it out. Okay, so hopefully you got a chance to try and figure that out, but for now, let me just show you the answers. So here's my console, by the way, if you can't see this right here. It's on the side here. So these are the answers that you should have gotten. If you didn't, let me explain to you how you get these answers. I'm just going to move this to the side a little bit. But we start off with integer 1 equals 2, okay? That's the important thing to see here, that it starts off as 2. And now what we're doing here is we're incrementing it by 1. So I've put here that this says this is an example of post increment, because as you can see here, the increment sign comes after the variable. So it's incrementing after this variable has been defined. So that's why it's going to print out 3 here. So hopefully all of you got that one. But this line of code should print 3. Now I've defined something called a pre-increment. Now, in reality, what's happening here is that it's actually incrementing the number first, and then it's going to print it out. So, well, in this case, it's going to print it out. But in reality, what's happening is the increment happens first, and then the variable is defined as that increment. So, when I'm explaining this, you're probably thinking like, oh, what's the point? Like, what does it matter? Either way, the number is going to be, it's going to increment regardless, right? And you're absolutely correct. But the time that the increment matters is when you're doing stuff like print statements or, conditionals, where you're going to see that this is actually something that'll matter, at some point. And here, I'm going to show you an example. So we know that from here, integer 1 equals 3. Now we're actually incrementing integer 1 here. Okay, so we're pre-incrementing it this time. So now integer 1 in this second system.out.println, integer 1 is going to be the value 4, which again, just as we've talked about, it's still incrementing regardless of post or pre. So it's going to print out 4. But now we come down to this line, and you notice that the integer 1 is actually being incremented in the print statement itself. So now we can see that the one that was 4 here, it's actually going to print out 4 again, because the increment hasn't happened yet. In this one, the increment happened first, so that's why I printed out 4. But in this case, it'll print out 4 and then it'll increment it. That's the difference between the post and the pre-increment. This kind of just shows you that. So now, as of now, this prints out 4. But then what's it going to do? It's actually going to increment to 5. But the 5 isn't going to get printed out. 4 is. But now integer 1 after this print statement is valued as 5. And then here we have another example of pre-increment, where you can see that it's actually going to print out 6. You know why? Because it's being incremented first, and then it's being printed out. So that's just the big difference between post and pre-increment, and you're probably thinking it's really useless and all, but you'll see at some point it does matter, especially in these kind of print statements. All right, so now let's go down to this next one. All right, so let's get started with the next problem set. So now this is going to be basically a combination of both compound operators and just operators in general. So we're just going to have a series of code happen where these variables are redefined multiple times and overwritten. And then you should be able to tell me what exactly gets printed out here. That's the final value for these variables. So I'm going to give you another chance to pause this video and then, let me know what A, B, and C's final values are. So just pause it now. Okay, so hopefully you got a chance to pause it and check it out, but now let's review the answers. So hopefully this is what you got as your values of 18, 16, and 0. So let's just go through this and talk about some helpful tasks. So, number one, you want to start by creating a table for A, B, and C and tracking the value of A, B, and C after every single line of code. So, I mean, I didn't create the table, but this is just definitely a helpful, you know, um, method for you to do. But you can always just do it in the comments like this or whatever you want to do. But let's just quickly trace through this now. You know that for A, we know that we're doing A times equals 3. So we're taking A, which is 6, and you multiply by 3. So now A equals 18, but B and C remain the same. B and C are not affected. Only A is affected. But now when we come to the second line, we see that B is affected. So now B is subtracting 2, which means that with B being 4, the new value of B is 2. So now both A and B have changed, but C is still the same. Now, here we are with line 3. We're actually using the new values of A and B that have been changed right here to calculate the value for C. So we know that A is 18 and we know that B is 2. So C should equal 0 because we're doing mod. And 18 divided by 2 equals 9, no remainder. So C equals 0. And then we're just, the rest is just the same as tracing this code. You see that, again, the value of C here isn't changing, but the value of A is changing. And that's something to keep in mind. And now you're probably asking, why couldn't we just do B minus equals A? But here's the thing, that doesn't work here because that would mean that you're subtracting A from B. But in this case, we want B to equal A minus B, not B minus A. So that's something that could be a little tricky, but make sure that you don't mess this up. And then, once we fully trace out the code, you should get the value of A equals 18, the value of B equals 16, and C equals 0. So that's just, one example of those kind of problems. Okay, so let's get started with problem set number 3 now. So in this case, we're really just working with doubles. It's the same, format as the previous one, but we just have doubles in place. So now you have to make sure you remember your double division, integer division, all that stuff. Again, in this problem set, I made it kind of easy. There really is no integer division that you have to worry about, but just make sure that you remember there's one fundamental thing about all the answers for x, all the final values of x, y, and z. So just keep that in mind. But again, take a second to pause. This will be the last set, so pause, take your time, do it, and then you can check your answers once you're ready. Okay, so hopefully you got a chance to do that. I'm going to reveal the answers now. Here you go. These are the answers. Let me just drag this out a little bit. There we go. So you can see here that we have some x equals 101.0, y equals negative 100.0, and z equals negative 10,100.0. That was the thing I wanted you to notice, was that all of them end in 0.0. If you just say 101, you're not going to get it right because that's not right. That would be an integer. But this is a double. And the whole point of a double is that it's a decimal. So anyways, let's get back to this code here. But as you can see here, first we're just starting off with subtracting the value of y from x and reassigning it to x. So same thing that we've been doing the past few times. It's just now we're working with doubles. But again, this is pretty straightforward. X should be 50 at this point. And then in this case here, we're multiplying y, which hasn't changed. Again, it has not changed, by 50. So I'm sorry, we're multiplying 50 by 2 because y is 50 right now, and we're multiplying y times 2. So 50 times 2, y equals 100. So now x is going to be, we know that x is 50 and we know that y is 100. That's just kind of, the way that you want to remember that. And now we're doing mod again. So in this case, there actually is a value for mod. And we're doing 25 mod 4, correct? So 4 goes into 24 evenly. That's 6 times 4 is 24, but it doesn't go into 25 evenly. So we know that there's actually a remainder of 1. So z is actually going to equal 1. And that's why, for that reason, you were probably wondering where we got 101 from. Maybe you messed that up. But that's actually where, is because when you're adding this z here to the x, so when you're doing y plus z, you know that your y is 100 right now, and we just add that 1. That's how you're going to get x equals 101. And same, that's the same method you follow for y and z. And in the end, we're printing out our final values, and this is what it equals. So that's kind of just the gist of following these. So yeah, that was basically the lesson of compound operators. You could see how they kind of work together, both just regular operators and compound operators, to create these more complex arithmetic expressions, and it also simplifies the code. So if you are taking APCSA, you're going to be expected to kind of trace this code just like how I made you do, and write the final values, or maybe just the value of one variable. But either way, this was pretty good practice, and you've probably gotten a better understanding of compound operators. So thank you so much for watching this video. Hopefully this was helpful, and hopefully you've developed a better understanding of compound operators and arithmetic expressions as well. And please make sure to subscribe to the STEM Spot for more computer science content as well as other STEM content. Thank you for listening, and I'll see you in the next video.